Hello my dear students, let's see the detailed solution of mini battle super 6 quiz rotational motion, right? So all the questions were very important beta, right? Let's see one by one. So now question number 1. Okay, let me first tell you the answer key. 1 second. Okay, you can match your answers. Okay, so that is the answer key. Correct answer of question number 1 is 9. Question number 2, AD option. Question number 3, it is 15.12. Question number 4, it is a 5. B option. Question number 5, it is ABD. And question number 6, answer is 5. Right. So see who is getting full marks. Getting full marks is very important. Right. Okay. Now, and more important is in understanding that what is your mistake. So that is our first question, right? So obviously it is a regular model, but still many times I have seen students do mistake in that. That's why I kept that question. Approach is a straightforward angular momentum conservation, right? So that repeated mistake by students here is what they write, that velocity of sphere is equal to r omega, right? But here rolling will happen on the moving surface. So the contact point and that point, the moving surface, center of mass of the sphere. So their relative velocity has to be what? R omega. Okay. So now what is happening in the question? So I will explain you first the question, that you are spinning it and placing on the plank. So in what direction first friction will act on the sphere? So it is now the upper part of the sphere, like this point, will try to move towards left with respect to plank, and plank will try to oppose this motion. So friction acting on sphere will be towards right, and friction acting on the plank will be towards left, like this. Okay. So it means plank will acquire some velocity towards left, center of mass of sphere will acquire some velocity towards right, like this. Okay. Now we can conserve angular momentum about any point on the ground, right? So initial angular momentum, initial what we have, only spinning, 2 by 5 m r square into omega. So now the Planck in our syllabus we know thickness is not given, means negligible thickness. So about this point, suppose you are conserving angular momentum. Now this point will be on the ground only, right? This point is not moving. So that is initial angular momentum with respect to this point, 2 by 5 m r square into omega naught. And then finally what will be angular momentum? The angular momentum will be this orbital part of sphere and then spin part of sphere, right? So that is total angular momentum when pure rolling on the plank will start. Now this plank, although it's moving finally, but it does not contribute in any angular momentum, right? Because the thickness is negligible, right? So r is 0. So by this I'm getting velocity of sphere 2 by 9 r omega naught. And now in this question time was required now. Initial velocity of sphere is 0, and we know when there is a slipping between sphere and plank, friction must be kinetic in nature. So acceleration should be mu into g. Friction force is mu mg divided by m, so acceleration should be mu g. Now time formula, so this time formula I am applying. Okay, so by that what I am getting, k value as 9, right beta? Okay, now next question. Oh, question number 2 was a very tricky question. The students sometimes say it's a scam, but it's a question trick. So there's a difference between a question trick and a scam, right? So it's not a scam. So here you need to read the question properly. So here with a skew you are striking. So when you are striking on any surface, in which direction you will apply force? So it's not like a sphere is having some roughness. So it is smooth. So on a smooth surface you cannot apply any tangential force, right? So if you are striking it with anything, you cannot apply force along the tangent. The only force that you can exert on a smooth body is along normal, and normal will pass through center of the sphere, right? Like this. So that is the force acting on the sphere, so passing through center, and the ground over which it is placed, that is also smooth. Okay, so it means what today? So only in this direction you are applying force, and horizontal impulse is j, right? So j is equal to change in linear momentum. So a option should be correct. The magnitude of linear momentum of the sphere is j, right? So I'm sure, so even the very good student who have seen this question first time might have done mistake, okay, but no problem with it. Just to see, okay, so try to rectify it. Now the other thing is magnitude of angular velocity of the sphere, right? So there is no external agent which is applying torque about center of mass of the sphere, right? So this force by this q that is acting and passing through center of sphere. So torque acting on the sphere about the center of mass is zero. So torque is zero means angular velocity is zero, no angular momentum. Okay, so D option. So correct option should be A and D, right? Okay. Now question number 3. In question number 3, we have to find, now mass of sphere is given, radius is given, is rolling without sliding over a smooth plane. So and we need to find its kinetic energy, right? So now for any extended body or system, we know how to find the kinetic energy. Concept of kinetic energy of a system extended body, so that is kinetic energy of center of mass plus kinetic energy with respect to center of mass. So now omega about center of mass, first of all we can write, because this point that's moving with velocity v, lowest point is at rest. So omega about center of mass we can write 2 by root 7. Kinetic energy of center of mass. Now center of mass is not performing linear motion, so that is the crux point here. Generally what we see that like a body, that body is rolling and center of mass is moving, so but it's not happening like that, right? So the center of mass is not moving, having translatory motion, it is rotating, right? So it is rotating. So kinetic energy of center of mass, you should write like that, half I omega center of mass whole square, right? Okay, right. So omega about center of mass. Okay, so here I should write kinetic energy with respect to center of mass. Okay, beta. And kinetic energy of center of mass is this quantity, moment of inertia about axis with respect to ground, into omega dash square. So omega dash means center of mass is having velocity v, this radius is r, so omega dash I can write v by r, right? Okay, so this 2 by 5. So what I am getting, so that is kinetic energy of center of mass, right? So now by solving, so I'm getting this 11.12, so total kinetic energy is 15.12. so surely many students have done mistake in that. Okay, try to rectify. Question number 4. So in question number 4, if you see, we are pulling the string downward with velocity v, and see, if you are pulling means you are trying to slide the lowest point towards right, so obviously friction acting on it will be towards left, right? So if some friction is acting on this uh, spool, what will happen, there will be velocity of center of mass towards left, so that is say v naught, right? So now here the concept is what, so concept is velocity of any point in rolling motion. So velocity of any point in rolling motion, we know it's velocity of center of mass plus r omega vector. So r omega vector is always along the tangent, right? Okay, so that is r omega vector, that is v naught vector. So now it's a net velocity I need to find along this line, right? So v naught alpha 90 minus alpha, so v naught sine alpha, this component, and r omega. So its difference will be what, r omega minus v naught sine alpha, like this we can say. So like this I am writing. Okay, so now then I'm getting v naught as this quantity. So since in the question they are saying magnitude only, so our B option should be correct. Okay, now question number 5. Question number 5 is very important. So now if you see, you are getting this lamina, triangular lamina. So approach is, for any such kind of thing, how we can find moment of inertia. So it is based on the concept of projection of plane lamina on a plane to find moment of inertia. So that is what the approach. And what will be brainstorming angle here, so that how to take projection. Now that is a plane lamina, so there can be two methods that can come in our mind, that we can take projection on YZ plane, or we can also think we can take projection on XY plane. So if I'm taking projection on xy plane, so what I'm doing, beta, I'm doing a mistake. So I am changing distance from the x-axis of different points. So I should take projection in such a way so that distance of any element I should not change from the axis. So moment of inertia about any axis is m into r square. R is distant from the axis. So if I am taking projection on yz plane, then it's all right. Okay, so that's why I'm taking projection. To find moment of inertia about x-axis, if I'm taking projection on yz plane, then I'm not changing distance of any elemental mass from the x-axis, right? And now it's a lamina, so mass distribution also will not change, right? So I'm taking projection on yz plane and finding moment of inertia, right? So like projection on of OBC, triangle OBC, right? Okay, I'll erase so that it can be like you can see it properly. So about x-axis, if I'm writing, then I'm taking projection and I will get this triangle. Now this triangle for the about x-axis I can apply perpendicular axis theorem. About y-axis and z-axis I can find, and then their sum should be I about x-axis. So that I'm writing, right? So similarly I'm doing for y-axis as well as z-axis, and I'm comparing the options. I will get A, B and D option I will get, right? So IY, IZ, similarly by taking projections I'm getting. Okay, now question number 6. So now here, just like in SHM I said, so few things are there that it seems that it is performing rolling motion, but actually they perform translatory motion. So it's that kind of question. So here approach is simple, that it's not rolling, it is translation. So all the questions that I am showing are those questions in which students generally they make mistake, right? It's not like very complex question, very hard question, but the questions in which students do mistake, right? So now like these points, all the points are moving on a circle with radius this length. Okay, so like this you can say center of mass also, center of mass also is moving on a circle. You can assume that is the length is L. Okay, so then net torque is equal to I alpha. So moment of inertia here again, we do not have to apply any moment of inertia for a plate formula, right? Simple, it's like point mass, it is going to rotate in a circle with radius as same length. So net torque is equal to I alpha. Alpha is A upon R, so A is d cos 30, so 5 root 3, right? So if you are comparing, you are getting value of K as 5, right? So these are all the important questions, go through it. Okay, and any question not clear, any step is not clear, please let me know. Okay, tell me, right? Okay then.